Hi, this is Mrs. Bazin, and today we're going to talk about electron arrangements. So there are 4 different ways to represent where the electrons are in an atom. So we're going to go through each one, so you can skip around if you need to. The first one is called the orbital diagram. What the orbital diagram does is it shows us which orbitals the electrons would be found in. So in the last set of notes we did, we talked about the s orbitals, the p orbitals, the d orbitals, the f orbitals. So this time we're going to show how those electrons actually arrange themselves within the orbitals. So in this type of diagram, the orbitals are shown as lines or boxes, and then the electrons are shown as arrows. So as we do this, we're going to follow the off-bow principle. So if you refer back to your chart or the diagram that we talked about in the previous set of notes, that shows us the filling order. So if you notice here, and I have way more lines drawn than what I need for the elements that we're going to practice with, but you can see below here are the orbital numbers and designations. So you have the 1s orbital listed first, then the 2s, then the 2p's, and again there's 3 2p's because there's 3 orientations. Then it goes to the 3s, 3 3p's, 4s, 5 3Ds because there's 5 orientations, and so on. So if you need more than what would be listed here, you would have to refer back to that diagram that you have. These are listed in order of increasing energy. So what that diagram helps you figure out is what's the lowest energy and then where does it go from there, which is the filling order for the electrons. So once you know where the electrons are going to go, once you get this set up, then we're going to fill in with our electrons. The other thing we have to do is we have to remember all those rules we talked about. We talked about the Pauli exclusion principle, which says that if you have 2 electrons in the same orbital, then they have to have opposite spins. We also talked about Hund's rule. And Hund's rule says that if you have electrons in degenerate orbitals, so those would be orbitals that have more than one orientation, like the p's, the d's, and the f's, then the electrons spread out first before they go back and double up. And that's because that is what causes that particular atom to have the lowest amount of energy. Okay, so when we do this, the first thing we have to know is how many electrons are in each atom that we're diagramming. So lithium, if we refer to the periodic table, lithium has an atomic number of 3. So that tells us that there are 3 electrons. So when we go to fill these, we're going to start with the 1s. So there's 1, 2, 3. So each one of those arrows represents an electron. We fill the 1s before we go to the 2s, and if we would continue on from there, we'd fill the 2s before the 2p, etc. So lithium, that's all we would have to do for that one. Okay, our next example is boron. Boron has 5 electrons. So we'd go 1, 2, 3, 4, 5. Okay, last example is carbon. Carbon has 6 electrons. 1, 2, 3, 4. Now here, we're in the p orbital, so this is where we have to spread them out before we double up. So instead of putting 2 in that first one, we're going to do 1, 2. So I have 1, 2, 3, 4, 5, 6 arrows, which represents my 6 electrons. And again, this is because of Hund's rule, where you have to spread those out before you go back and double them up. The other thing you notice is that I always started with an up arrow. That's just the convention where you start with the up and then you put in the down arrow. And again, showing the up and down arrow is the Pauli exclusion principle, that if they're going to be in that same space together, they have to have opposite spins. Okay, so the next configuration that we can do, or notation we can do, is called the electron configuration. What this does is it eliminates the arrows. So it's still going to show us how many electrons are in each orbital, but instead of just showing the arrows, it's just going to kind of condense that, and we're going to use numbers written in superscripts to show the numbers of electrons in each orbital. So if we refer back to what we just got finished with a minute ago, so I'm going to fill this in real quick over here. So lithium, we had 3 electrons. We had this, this, and this. So we're going to translate that into 1s2. So the 1s orbital has 2 arrows, or 2 electrons, and then 2s1. The 2s has 1 electron. For boron, remember we had 5, so it was 1, 2, 3, 4, 5. So boron's electron configuration is going to be 1s2, that's from this one, 2s2, that's from this one, 2p1. Okay, our last example we did was carbon. Carbon had 6, 3, 4, 5, 6. Now on these, all of the 2p's we can combine together. So when we do this one, we're still going to have 1s2, 2s2, and then we'll have 2p2. We can put those all in the same notation.